So this is the cubic function that has been given. Okay, this is the function that you have to use to sketch the cubic graph. You know the cubic graph looks like a snake. Alright, so if you look at the two shapes of a cubic function, one starts with an increasing part. Okay, that is if the value of a is greater than 0 or positive. And the other one starts with a decreasing portion. That is if a is less than 0 or negative. So what we're trying to talk about is that when you are given this function, you know already that this is the factorized form of the cubic function. Meaning we have three factors here, which can be converted into roots. When I mean roots, I mean the value of x, when substituted into the function, the entire function will be equal to 0. And some people call it the x-intercept. Now, so if according to the question, you are to determine the y-intercept. You know, at y-intercept, the coordinates of x is usually 0. So if you look at the function where we have x, you just substitute 0 there for x, such that you can get the value of y. So that is what we say g of x simply means g of 0, meaning x is 0. So here, after substituting 0 into the function, you get 36. So we call this one the y-intercept. Now the y-intercept is a point that is located on the y-axis, where x is 0. So this 0 and 36 have been located here because it's a positive value on the y-axis. Now, we come to look for the x-intercept. At x-intercept, y is also 0. Now, what do we mean? X-intercept is a point located on the x-axis that is intersected, or that the graph has cut. So, if we draw a graph and the graph cuts the x-axis, the point at which the graph cuts the x-axis becomes the x-intercept. Same applies to the y-intercept. So at this point, we already have the factors. So since y is equal to 0, it means the entire function here is equal to 0. And if each bracket is equal to 0, then basically we solve for the value of x. You realize that x is equal to 6, or x is equal to 3, or x is equal to -2. With the sense that when you bring this back here, it becomes negative. Alright, so now we continue by looking at the other side of the function. It continues to say, determine the equation of the cubic function in the standard form, ax cubed plus bx squared plus cx plus d. So it means that when you expand this, you are definitely going to get this. This is what I have done. You take the first two brackets, you try to expand it, you get this, and then you use the first bracket now, you multiply. Note that not everyone starts expanding the last two brackets. Some people can also start expanding the first two brackets and later multiply with the third one. It depends on where you want to start. So when you expand, you will end up getting your standard form of the cubic function. Remember, this is supposed to be in four folds. For example, there are 4 terms here. We have ax cubed plus bx squared plus cx plus d. Now, if you look carefully here, it looks like we have 1, 2, 3, 4 terms, but something is missing here. We have the x cubed, we have the x squared, then we have x to the power of 1, which is missing, which means that the value of c is 0. So when 0 multiplies x, basically the whole item becomes 0. Now, so from there, the question asked us to find the turning point, the coordinates of the turning points of the function. Now, if you are determining the turning point of a cubic function, the first thing we have to do, as the rule says, is to determine the first derivative. We have to differentiate the function. Now, in differentiating the function, we've realized that we've got 3x squared minus 4 14x here. So 3x squared minus 14x must be equal to 0. Now, derivative is gradient if it is not equal to 0. But when the first derivative now is equal to 0, then it is no longer called gradient. It is now called the x-coordinate of the turning point of the function. So in that case, we equate the derivative to 0 so that it will no longer be called a gradient, but the x-coordinate of the turning point. So this is what we've done. We factorized here, knowing that we have the common factor which is x, so we have it here. In fact, when you factorize, x now is equal to 0, and the whole of this bracket is equal to 0. Therefore, if you solve for x, you know what is definitely going to happen. I have named the x values x1, x2. That is by my own discretion because there are two x values, so I want to distinguish them. Why am I doing that? There are two coordinates of the turning point. So these x values, each x value represents the x coordinate of one turning point, and the other x value represents the x coordinate of the second turning point. So now, how do we get a point is made up of x and y coordinate? So we've got the x coordinates of the turning point. So we have to find the y coordinates in order to call them points. So you take this first x value, you substitute into the original function, and then you get a value here, which is 36. Then you take the second x value, which is 14 over 3. You substitute into the function. I'm talking about the original function. This and this are the same. This one is just a simplified or the factorized form of the standard one. So any of them that you use, you get the right answer. So here you see that when we substitute the two x values, we got 36, we got negative 400 over 27. So basically, these are the two turning points we have. Effectually, we have these points, all these points, the turning points here, the x-intercepts, the y-intercept have all been plotted here on the graph. So all we need to do now is to join the points or link them up. So now I'm saying we have to determine the shape of the function. So I say if a, I mean the coefficient of x cubed is what we call the a value. So if a is positive, meaning greater than 0, this is how the shape will look like. If a is negative or less than 0, this is how the shape will look like. Now we know that the coefficient of x cubed here is positive, is a positive value. So definitely we are going with which one now? Positive. So this is the graph we are going with. So we link up the points. So I take my graph and then I go through. Now remember that the y-intercept of the graph is the same as the turning point. So note that. So when we reach this place, we have to turn. You see? So we have to join the other coordinates of the turning point and go up. So basically, this graph now looks like this one. So this is how we can sketch a cubic graph in short form. Thank you.